Good afternoon, also from myself. To be honest, I'm a little bit excited because it's my first time in India. I like it so far, and my first time to give a speech in front of this huge audience. But I try my best. Today we're talking about the state-of-the-art quality control for refillable PET bottles, recyclable PET and CO2. I would like to introduce you to Unisensor, short information about Unisensor. The company is founded in 1990 by Professor Krieg. We are a family-owned, independent company. Mr. Krieg is still around, the president, and yeah, we are specialized in the identification of substances, liquids, solids, and gases in industrial processes. Our core technologies are optoelectronic absorption, fluorescence, and Raman spectroscopy. We are selling the machines worldwide. I will show you now the different products and also providing the after-sale and the service from Unisensor. I'm from Germany, and also our headquarters is in Germany. Just a quick overview about our product range. At the top, we have a product for the recycling industry. That's the power sort. This is my main chapter today because I would like to talk about the reuse and recycling of PET beverage bottles. This is one of the products which is there for recycling of PET flakes. I go over to the beverage industry. There are refillable bottles which needs to be identified or controlled about the qualities. Next product is printing industry, gas suppliers, the carbon scan which analyze the purities of the CO2 in the beverages, and an ongoing project, the water trace for water analytics. Let's start with the online CO2 quality control. This is an example. We are delivering the turnkey solution. Means the machine is calibrated and is able to detect and analyze or to detect substances inside the CO2. This is an example of installation, CarboScan 150. This show you, this is a self CO2 manufacturer, and the goal is to analyze the CO2 online, which goes into the beverage later, and the CarboScan analyzes the qualities online. This is the biggest advantage, and gives the bottlers or the gas suppliers, depends where the application is installed, quality control. And yeah, I'm a little bit in rush because of the timing, and my presentation is quite long. For any further questions, I'm still the whole day here around. Okay, this is a quick overview about our worldwide installations, 170 in above 57 countries, not in India yet. Okay, next chapter is the new plastics economy for PET bottles. Transformation to the circular economy, new plastics economy for packaging. The graph will just show you how important it is, or it becomes more and more important, the reusing and the recycling of the PET bottles and the packaging. We would like, or it should be the best, to create an effective after-use plastic economy in terms with recycling, reuse, to close the loop, to close the circular economy. To avoid that any plastics goes into the environment, especially in the sea. Just some numbers. Recycling of PET bottles. Approximately today 500 billion PET bottles are produced every year, means roughly 15,000 bottles every second. The collection rate worldwide is around 50%, which is not quite high, but in India there are around 90% of the PET bottles collected, which is a really impressive rate. India does a really good job. And this is an example of some big brands which like to follow the new plastic economy. They would like to increase the content of recycled material in the production of new bottles. Example of Coca-Cola is 50% recycled content up by 2030. Danone is pushing it more. They would like to go up to use 100% recycled PET material in a new bottle, content in plastic bottles by 2025. Yeah, this is a lot of numbers, but I would like to say again that the recycling rate of India is really impressive. And in India, more than 92% of the PET is recycled, inclusive of their home reuse. And it goes mainly into yarns and fibers, 91%, straps 5%, sheets 3%, others 1%. Not so far, there is no bottle-to-bottle process at the moment ongoing. Let's go over to the new plastics economy with Unisensor technologies. Unisensor is providing different products, and especially these three examples are implemented in the packaging PET industries. Example is for the refillable PET bottles, we have a cooperation with KHS of the big sniffer machine, which is quite common in Europe and also in South America. These are bottles which are PET bottles, which are a little bit bigger, which can be reused a certain time, up to 25 times. They get washed and get refilled, but they need to be analyzed if there are any foreign smells or liquids inside which is not possible to wash out. So the sniffer, the mechanical parts is provided by KHS. Our main components are the sensor systems. So we include in the sniffer, the big sniffer, up to 4 systems, including an IR spectrometer, which, let me say, they check the whole wavelength and the whole range about any foreign substances which are in the bottles. The smaller brother, I say, it's linked. It's the 5-gallon sniffer with a UV spectroscopy. And for single-use PET, we brought on the market 2008 a Parasol 200, which is the flake sorter for PET flakes. Yeah. Just a quick picture about the AquaScreen, the 5-gallon sniffer. This is maybe the start to, because my main chapter, I said, it's today the recycling or the sortation of the PET flakes. This is a good overview about the PET recycling process scheme. It's mechanical thermal recycling. The target and the goal is, or the journey starts always the same. The bottles needs to be collected, okay? After the debelling and separation, manually, mechanically, sensor-based systems, they are sorting the bottles for color, metal, and foreign material on the bottle shape size. Then they go to the grinding. Then you receive really small flakes, around 20-25 millimeters. They get washed, separated, mechanically wise, and there are some camera-based sorters which sorts the flakes for color. But we are providing a flake sorter which eliminates any foreign material which is left in the PET stream to upscale the final quality for flakes, because in the thermal process the flakes goes usually in the extrusion. After that there can be an SSP, solid state process, for a decontamination, and altogether is necessary to receive a food-graded PET with those sorted PET flakes and afterwards produced pellets. You can go, let me say, from bottle to bottle in a really safe and secure way. Or other applications like strapping, sheet, fiber, and it's quite similar the quality to virgin. This is why the biggest brands are producing meanwhile new bottles out of recycled PET material. What is the challenging at all? What is our challenging? Because there are already different solutions on the market which using different technologies. And let me say 20 years ago when we started development, we never would like to copy an existing technology, or we would like to solve the existing problems, because the sortation, the existing sorters does a really good job. The challenge for us is to identify clear material, clear foreign material in a clear PET stream. This is, I don't like the picture, but there is an example of foreign plastics or foreign polymers, but you cannot see it because they are mixed inside the PET. Here you can maybe mention the silicon membrane. Yes, let's go over to the PowerSort 200, which gives, we are usually in the whole sorting stage or in the whole sorting chain, usually the last machine to upscale or to give the material the final quality. How do we do that? The plastic sorting based on high-tech, high-speed laser spectroscopy. The principle is, let me say, quite easy, mechanically wise. We just transport the flakes over the machine. The material slides down, and inside our PowerSort there is like a laser scanner, like in a supermarket scanner, and constant rotating laser. And the laser hits the material passes the machine or passes the measurement area. What happened if the laser hits the material? The material starts to emit light. It's not a reflection, that's the big difference. It's creating a fluorescence. Fluorescence means the material emits light on a certain or a specific wavelength. This light is collected by our own developed spectrometer, and each polymer, this is the advantage, each polymer has got its own, let me say, spectra. We call it fingerprint. Means then we need to identify or to calculate in a short time which kind of material was in front of the laser. Yeah, and then it's just a decision, was it good or was it not good? Let me say, if it was PET, then it just passed the machine. If it's something else than PET, we blow it out with air. Yeah, excuse me, this is, yeah, we call it the fingerprint, the physical fingerprint principle. An example of the spectra, how we generate the spectra. This is also really easy to recognize for the human eyes that those spectra, blue is the good material example in comparison to the red spectra, which should be at contamination. You see it with your eyes, it's a big difference here, so the differentiation is quite easy. The task or the main difficulty for us is to generate such a fluorescence, and this is what we do with the laser. By the way, we do up to 1 million spectra in 1 second. Means roughly 3 tons per hour is running over one machine and get analyzed, and we do not a double sortation, so we achieve the food grade quality with only one sortation. Just to give you an overview about the wideband, the measurement range is from our machine. We are using the high-speed laser spectroscopy, and our laser, a small secret, we are using different wavelengths, and we are going from the deep UV, which is really strong, over to the visible light, to the near section. There are already visual methods on the market, camera systems, they are using the visible area. The near infrared methods are using the near area, of course, and we would like to cover the whole range. Of course, our machine is not the wonder machine which you can feed with total bad mix. Of course, there are some pre-sortations necessary, like a metal extraction. We also unofficially recommend that there is a color sortation in front of us, minimum on the bottle side, but these are fine details we can discuss later. An example, what can you imagine? What is the final result of our sortation, or what happened? As I said, we separate or we split the two materials in a good fraction and in a bad fraction. Without any process or without any laboratory analysis, you cannot see that there is a difference in the two fractions. Either in the good fraction, as I remember, please, I mentioned there are clear contaminations which cannot be recognized, and they, of course, all foreign polymers or materials should be in the reject, and the ejected material in the bad fraction. What is an official method in our plants or in our and the factories where we deliver the machine? There is a really cheap and easy oven test. You put the material for 2 hours, 200 degrees in an oven, yeah, like an oven at home, and every material which is not PET creates or changes the color. Of course, here in this example, everything in the accept, in the good material, keeps the clear color, so there are no any foreign materials left. And here in the example, you see everything which becomes yellow. This only happens after the oven test. It's the same. We are usually the last machine in the whole chain, directly in front of the extrusion. So all the material which goes in the extrusion would get black or yellow if it's not sorted by our laser sorter. More detailed example, what you can imagine about we call it reject. This is a typical sorting result before heating and after heating. We split it a little bit to give you a better example. What does we extract or what material we push out with air? Especially PVC, which is normally clear, or foils, before the oven test becomes black. So the people in the laboratory, they just take 500 gram samples of each produced big bag, and then the ladies and gentlemen count the black material and count them together, and then they measure the weight. Yeah. PVC or any black material is quite easy to identify, but we are specialized also to extract material which becomes light yellow. Why is the material not black or dark yellow? These are PET. This is PET material which obtain maybe an additive inside as a compound, or it's a multi-layer, or there is a layer attached. Means it's the flake itself, it's PET plus something else. We do not know the concentration. We do not know the foreign material. Our spectra, what we are receiving is that the main information is PET, but we see also the additive, and this is also a big advantage for us. And this information you can only receive when you use a laser light as a light source. Yeah. So nobody of our customers, nobody of our bottle-to-bottle customers would like to have those yellowing flakes in their final material, for example, nylon as well. And our reject rate is our final reject rate. We are able to do a resort of the reject to justify the reject, and then the ratio is between 3 to 1, means 1 good flake is in the final reject and 3 bad flakes. So we have a really less reject, a high yield, a high throughput, and I hope also a high good quality in the final product. An example of our advantage as well is we are able to detect really smallest impurities. Small, people asking me, Dennis, why are still there fines inside or small particles in the material? Although the process or the material gets sieved, it's impossible to sieve it away. You would lose too much material. So we take care about it because we have such a high resolution. Again, we are analyzing up to 1 million spectra per second, and especially here you see the resolution. Each square stands for a detection and spectra. So we do not see the shape of the flake, we just make a continuous measurement. Especially in this example, you see a PET, maybe 80 to 85% is PET, but there is a foreign material attached. Usually it could be glue. So we need to eliminate this material, and although already one measurement is enough to say the machine that we would like to eject this flake. In comparison to existing technologies or the other existing technologies on the market, which have got maybe roughly around 100,000 measurements. And therefore you see the resolution is not so high, and they would not get out such a flake with glue. Example of our installation in process, we are installing and delivering the machines worldwide, more than 70 machines. And last but not least, thank you for your attention.